Hi, we've had a pond in our backyard for 15 years or so, and one of the chores that I have in the fall as winter approaches is to keep track of the temperature in the pond, because once the temperature of the water drops below 50 degrees Fahrenheit, I need to stop feeding the fish. It seems that their metabolism drops as that temperature of the water drops, being a cold-blooded creature, and if you feed them below 50 degrees, they have difficulty digesting the food. So I keep an eye on it, and one of the easiest ways, of course, is just to take a thermometer and put it into the pond, let it sit in the water for a minute or two till it stabilizes, take it out and read it. But that's a little bit tedious, and I decided this year it'd be fun to make something a little more high-tech. My objectives were to have it continuously readable, so I need to have a sensor that's in the water all the time. I want to be able to see it from inside the house so that I don't have to go out and check some display or whatever in the backyard. And I've come up with a system that's very simple, uses simple components, and I think works very well. Let's take a look at the parts that we're going to need to build this. I decided to base it on an Arduino. You of course need some sort of microcontroller to get the temperature information from a sensor. And the Arduino you use is really pretty much up to you. You certainly could use an Uno, the original Arduino, although it's fairly large for what I'm doing, but it would work just fine. What I decided to do was to stick with the Arduino Pro Mini, very small, not much bigger than a couple of quarters put together. And I also used on one end the Pro Mini, on the other end, again keep in mind this is wireless, the Nano. Now that's again pretty straightforward with the Arduino. All the code is on my webpage, so if you want to download that, you can just cut and paste it into your program. The big thing that the Arduino needs to do, at least the Arduino on the pond end, is to get temperature information. And I decided to use a little 3-pin device called a DS18B20 from Dallas Semiconductor. It's a factory calibrated one-wire interface temperature sensor that works very well, and the fact that it's small makes it easier to waterproof, I think, than some of the larger ones that you use. This only has 3 wires coming out of it. One is +5 for the voltage, one is ground, and one is the data line. One important thing that I want to mention, of course I just dropped it, you have to put a 4.7K resistor between the data line and the +5 line. That pulls that data line high so that the data is transferred more successfully. So you need in the temperature end of it, the temperature sensor and a 4.7K resistor. Now I've got a sensor like that right here, and I've got 3 wires connected to it. This is kind of messy. This was just an experimental one, but I've got the resistor right there, the plus, the data line, and the ground, and I'm just using some servo extension cables to connect everything. You may be familiar with these 3-wire cables that you can use on servos, and that wire connects to the Arduino. This Arduino again happens to be a Pro Mini. This would go on the pond end of it, and I wired 3 wires from the temperature sensor to it, +5, ground, and data. The data goes to pin number 2 on the Arduino. And that also brings us to the other component that you need. In order to get data from out there, which is about probably 30-35 feet away as the crow flies, maybe closer to 80 feet if you had to run a wire, we need to bring the data into the workshop. And I opted to use one of my favorite little devices. This is an HC12 serial transmitter receiver. Well, what does that mean? Let me pull another one out. These are tiny. As a matter of fact, that little bag has 3 of them in there. When you get them, you get the board and an antenna. That's the antenna, which is about an inch long coil of wire. You solder that antenna to a pin that's marked as antenna. Connect this up to transmit, receive, ground, and 5 volts. And that's all you have to do to get this thing working. You can do all sorts of configuration on the HC12 to change channels and frequencies and speeds and so on, but the default 9600 baud works beautifully. It's as though I have a wire running from the pond down to my basement. I send data into this chip out at the pond, and at the other end, down here, I receive it and convert it into data that the Arduino can deal with, and it's going to give me the display. That brings us to what's inside the house. I chose to use a small 2-line liquid crystal display that has an IC2 interface soldered to the back. Here's one that's all wired up. And this is a prototype that I put together. No soldering, just plug the wires in. The Arduino Nano, I have the display connected to A4 and A5 plus 5 and ground. And that, of course, connects to the back of the display. This is the radio receiver, in this case, that picks up the information over the air. I have plus 5 and ground, and I also have a data pin going from the transmit pin on that to the receive pin on the Arduino Nano. I built up another one, this is the receiver of course, and put it in a little box to make it cleaner. This box is yet to be glued up, so we can take it apart. And there's a very compact wiring job with the transmitter receiver, the Arduino, and this of course is the liquid crystal display. One very important thing I forgot to mention, make sure when you wire this up that you have an easy way to disconnect the transmit and receive lines that go between the HC12 and the Arduino. I just have little plugs similar to the plugs that you use with the servo cable. They're also called DuPont plugs that you find with a lot of different Arduino kits. The reason for that is the serial transmit receive pins that are used to communicate with the radio are the same pins that are used to program the Arduino. So if you don't disconnect that, you're not going to be able to program the Arduino. You will get an error for sure. Okay, now, once we get this sensor hooked up to the wire, this wire, by the way, can be quite long. I used to run one of these from the pond by wire clear here into the basement. And as I said, that's about 80 feet. So there's no problem running long distances. I just used the servo cables, and I could easily put a 2 or 3 foot extension in there if I want to get this into the water. But how are we going to do that? Well, we surely could take silicone sealant and probably seal this whole thing up with silicone seal, let it dry for a day or two, and put it right in the water with a little weight to get it underwater. But I opted to do it a little bit simpler way. Anybody recognize this? Strange little black tube. I'm a cyclist, so I've always got old failed inner tubes laying around. Here's a piece of inner tube. It's just a hollow, probably 5/8 diameter piece of rubber tubing. And I took one end of that, folded it over, folded it over, folded it over, and then put a couple of cable ties on there to give me a nice watertight end. I cable tied a couple of steel washers on there as weights, and I pushed the temperature sensor, and its wire clear to the end, so it's down here, can feel it, and the other wire comes out at this end, and I've got that end tied off with a couple of cable ties. Any water that goes past the first one's going to get trapped in this little intermediate. I don't think it's going to get past the second one. And I simply plug this into the transmitter board. If I can find that here. Here we go. Plug that in here, observing the proper polarity. I'm using the red, white, and black wires, obviously, to match up with the others. That fires up the Arduino, the transmitter, so it's immediately transmitting data from this device out into the air, and then we try to pick it up down here at the basement. What I'd like to do now is to get the outside part of the system ready to put out in the pond. What I've done is to take a little piece of double sticky tape to connect the transmitter receiver board to the Arduino, and I've cut a couple of holes inside of a small I guess that's a fruit cup or something, container you can get at the dollar store. I think I paid $6 rather for 6 of them. And I cut a hole in the side for the power and a hole in the side to let the 3-wire cable for the sensor come out. And I'm going to push that down into that container and put the lid on. And the nice thing about this is it's a little above the bottom of the container. It's being held up by the wire, so if any water does get in there, chances are good it'll just stay at the bottom. And I've got a hot melt glue gun here, and I'm going to just fill those 2 holes with hot melt glue, which does, not the best job in the world of waterproofing, but chances are good it will suffice here. Okay, while I'm waiting for that to set, another option for the sensors is to use plastic pipe. Here's a couple sections of plastic pipe and an elbow and a cap, and you simply take this cap off at the top, push the wire and the sensor down to the bottom, put that back on. I used a little bit of putty up there to seal it, and that works real well too. All right, we're just about ready. I'm going to take this outside and put it into the pond, and we'll take a look at the numbers that we get on the display inside. Okay, the temperature transmitter system is out. The sensor is in the pond, and I'm back in the basement. Here you can see the display on the 2-line LCD. It says pond 53.71 degrees Fahrenheit. MN equals 53.71. In other words, the minimum is what you're seeing right now. And we do have the temperature dropping a bit during the day. The maximum is just a little bit over that, 53.8. And it's about 47 outside right now, so that minimum is going to continue to drop. One of the things I'd like to show you, if I hit the reset button on the Arduino, you'll see the HC12 test pop up, and then a couple of seconds later, it's looking for a radio signal. There we go. There it goes. Took a couple seconds to get synced up. Now again, it's 53.71. And the display, it's a little hard to read with the lights on above, but hopefully you can see that on my cell phone. One other thing I'd like to show you before we leave this particular segment, because the transmitter and the receiver are not handshaking or doing anything special like that, the receiver is just picking up what's being transmitted. You can have more than one receiver. Here I've got the little box showing the pond temperature 53.82, and over here showing 53.82 as well. You'll notice the minimum, maximum can be different because they were reset at different times. And of course the reset would clear the minimum and maximum, and it would start over again with that. But you could have, one of these upstairs and one of them downstairs or what have you, and without any great difficulty. What you can't have is 2 transmitters. That would confuse all kinds of things. I think you'd agree that the system we just looked at meets my design criteria. It's a waterproof temperature sensor, and it sends information that I can view in the den and down here rather easily. Now, there are other alternatives. Here's one that I bought from Amazon a couple of days ago. This is a floating temperature sensor. It's got a little weight down here and a temperature sensor in the bottom. And it has a liquid crystal display. Right now it says the temperature is about 71, 72 degrees. A little solar panel and a backup battery. So you can float this in your pond, tether it to the side, and then kind of bend down a little bit and read the display to see if it's above or below 50 to feed your fish. Not a bad thing. The downside is you'd probably need to pull it out as soon as it got much below 40, 35 degrees, because if the pond begins to freeze around this, I think it would crush it. But for a lot of readings, this would work just fine. Another alternative, you might have noticed there's a blinking light over here. Well, what is this thing? This could be used to give you the temperature by not leaving the house. It's got the temperature sensor here on the side, a couple of LEDs, and notice they're brightening up now. 1, 2, 3, 4, 5, 6, 7, 70, 1, 2, 3, 73 degrees. And then it goes back to sleep. You could put this inside of one of the little containers from the dollar store, run the temperature sensor into the water using one of our waterproofing techniques. Here we go again. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. That went up a little bit because I was fooling around with it. And if I grab onto the temperature sensor, it'll even be higher the next time. So you could view this through a window or a door and see at a glance. Here we go, one more time. Should be a little higher. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 78 degrees. You might ask, well, where did this thing come from? That seems like a strange thing to invent just to measure temperature in a pond. It actually came from this. Were you wondering why there was a bicycle helmet back there? There's a circuit on the bicycle helmet that's identical to the circuit there. And before I forget to mention it, this is not an Arduino-based device. This is a PIC. It's actually a surface mount board and a PIC processor that I programmed using PIC Basic. Anyway, if I turn it on, that just flashed out an F in Morse code for Fahrenheit. And 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, whoops, 72 degrees. So I've got LEDs on the front that flash out the front, LEDs on the back that flash out the back. The background on this thing is I wanted to have flashing lights on my helmet because I think it makes a very good place to allow cars and such to see you when you're riding on the road on a bicycle. And I decided if I'm going to have flashing lights, I might as well have them do something intelligent like tell me the temperature. So I wrote up a piece of software, designed the board, and it works very well. A number of the guys that I ride with have these on their helmets. And this was also the cover story on Nuts and Bolts magazine a few years ago. So something that you certainly could do with the pond or a bicycle helmet. Hopefully this video was of interest. I appreciate the time you took to look at it. Thank you.